Our next speaker joining us is a Harvard professor and also the founder of Bionics Lab. So we have our next speaker, none other than Shriya Srinavasan. So on that note, over to you, Shriya. Thank you so much for joining us today. Over to you.
Good afternoon, everyone. Through the cultures, over centuries, humanity has always desired to understand the mind, how thoughts emerge, how decisions are made, and ultimately what makes us truly conscious. At the root of this, giving rise to the mind, is the nervous system. This is the biological substrate that allows us to move with ease, to allow us to have emotions and behaviors, and ultimately give us our sense of self. Dissecting the mind is not a modern obsession. The early pioneers were the monks and philosophers who sought access to their neural control centers, were able to change their heart rates and their perceptions, and even access different layers of consciousness. Today, engineers and scientists are using modern tools to tackle and gain access to the mind, to the nervous system, and be even able to modulate it. This is important because the nervous system is responsible for the function of so many of our organs. And so if we are able to access it and communicate with it, this gives us the opportunity to potentially treat many diseases at their root. This is at the core of our mission at the Harvard Bionics Lab. Specifically, we're asking how we can use neural engineering techniques to rewire our physiology, to unlock our biology, move with extraordinary control, and perhaps one day expand the boundaries of our minds and bodies. So let's start with the basics. What are neural interfaces? Over the last few decades, the field has developed incredibly sophisticated technology that allows us to record signals from our nerves and muscles and be able to decode intent, to then be able to control robotic devices like prostheses. Now, these have really come a very long way and allow patients to have movements, etc. But for us to gain very high levels of function, we need this communication to be a two-way street. We need to both be able to read and write to the system, and this has been a challenge. Despite the sophistication of these devices, they don't send feedback about their movements, their velocities, their forces back to the user in a naturalistic way. And that lack of integration continues to be a bottleneck for our ability to use them with ease. To overcome this, in work at the MIT Biomechatronics Lab, we designed new types of surgical paradigms to actually re-architect the nervous system, to prepare these tissues to be able to interface with devices to both send and receive signals. In the case of amputation, for example, we reconnect the nerves and muscles in such a way to design the signaling circuit so that the body receives natural sensory feedback and is able to receive information from a prosthetic device. This allows patients to know where the limb is in space and better control it. We started this work about 10 years ago, and now it has been done in over 80 patients, and the results have been very promising. We see that the patients are able to grasp and manipulate objects with much greater fidelity. They're able to move, walk with much greater ease, control, and speed. And most importantly, integrate and interface with their environments to a much greater degree, as you'll hear from this patient. With amputation, the brain reorganizes. It loses its ability to have limb awareness and changes the circuits that are responsible for pain, and sometimes leads patients to have something called phantom pain, which can be extremely debilitating. By restoring and preserving these circuits in the human body, we found that our patients were actually able to have better sense of their phantom limb, as well as experience much more decreased pain on a daily basis. And this was one of the biggest outcomes of our study. In fact, one of our patients told us, "I went from a life of chronic pain, 9 meds every day, sleepless nights, finally to sleeping through the night every night." And this really showed me the power of engineering our bodies and our physiology. Recently, we've been trying to take this a step further to see if we can introduce new types of sensations to the body. We've taken nerves that normally go to skin, sensory nerves, and placed them in muscles. And what we're able to see is that we can actually produce new types of sensation from this muscle that perhaps we can later connect with virtual worlds or even exoskeletal devices to allow the humans and machines to really work together and communicate in a unified manner. Now, my initial work focused on the movement and sensation in our peripheral limbs. But as I began to see the power of this type of engineering, I thought, what about our internal organs? What about their movements and their sensations? And that really brought me to the enteric nervous system, or the gut's brain. Consisting of over 400 million neurons, this is a web that runs all the way from the esophagus to the anorectal canal and controls everything from your digestion and motility to your hormones, your focus levels, and even your stress. Because the gut and the gastrointestinal tract is so connected to many organ systems, diseases of the gut result in profound, debilitating effects on the quality of life. Despite its influential role, until recently we hadn't really designed many neural interfaces for the enteric nervous system. And this is because the gut has a tortuous anatomy, its internal system is constantly moving and having pulsatile peristalsis, and the lumen is quite harsh in terms of its chemical environment. Designing around these challenges, we designed neural interfaces in the form of an ingestible robot. These can be swallowed, travel to the right part of the tract, and release chemical or mechanical energy to then stimulate the enteric nerves in the gut. So, just like neural dysfunction in the periphery leads to movement disorders, neural dysfunction in the gut can lead also to motility disorders like constipation and gastroparesis. Engineering around the challenges and overcoming this, we came up with a device that can be swallowed, which travels to the right part of the intestines and activates, pops open, makes contact with the lumen, and produces electrical contractions that then increase the motility by over 200% in models of ileus. This is a promising technology for diseases like constipation and ileus. But beyond movement, I was also very curious about the sensory circuits in the gut. And specifically because if we're able to communicate with the sensory circuits, we then have a powerful tool against diseases like obesity that actually corrupt these circuits. So I was curious, could we do something to change sensory function and thereby influence the behavior of our gut and the behavior of our bodies? For this, we designed a pill that actually mechanically stimulates and activates stretch receptors in the gut, fooling the brain into thinking that the stomach is already full, releasing hormones and creating a sense of satiety and depressing appetite. In preclinical models, we saw almost a 30% reduction in food intake. This presents a pretty promising approach to treating diseases like diabetes and obesity. Now, ingestible neuromodulation, we're still in the very early days, but I think the approach is very promising because the gut is emerging as an early biomarker for many diseases. So with our ability to access it and communicate with it, we may be able to not only better unlock the secrets of the gut brain, but also be able to build and implement precision health monitoring technologies to improve our health and well-being. Neural interfaces aren't fundamentally about devices. It's about unlocking the body's control systems. When we restore sensation, we restore agency. When we reshape pain circuits, we change experience. And when we engage the gut, we're able to change behavior. When we go from treating to redesigning, we suddenly go from just solving to imagining. And so at this frontier, I no longer ask, what can I restore that's been lost? I'm starting to ask, what new capabilities can I unlock? What lies beyond? Thank you so much.